Okay, here we're back in part 4 on section 9.3. So here we're going to actually have to graph nonlinear inequalities. And so we're going to basically graph it as it were an equation, not an inequality. So we're going to change any inequality to equals, graph that, and then the key thing is, and here I always forget this because I always look at the inequality or the equality after I've changed it, and then I always draw a solid line. But if you have greater than or less than or less than or less than or equal to or greater than or equal to, you're going to use a solid line. And if you have strictly less than or strictly greater than, then you're going to use the dotted line. And so you'll probably catch me doing always solid lines and then going back, oh, and then have to erase and do dotted lines. Okay. And what we're going to do then is we're going to test a point in each region to see if the inequality is satisfied and shade any region that is. Okay. And then if it's a system of equations, we're going to draw all the parts first, and then we're going to test the regions. And what I like to do is I'll draw all the parts, then I'll go back to the original equations, and I'll say, okay, well, the y has to be, greater than this, so it's going to be above. Or if y is less than, then it has to be below. And try to narrow down my regions I have to test, because sometimes you might have quite a few regions. Now, this doesn't actually have to be when you're hand drawing it super exact, but if you're doing on the computer, you can always choose a vertex, and you can choose in one more point and draw things. So it's sometimes nice that way, but with hand drawing, it's not always going to be perfect. So if we think about this and we convert that to y equals x squared minus 1, what does that remind us of? Well, x squared is our nice x squared function. Minus 1 means we move x squared down 1. Okay. So if we move x squared down 1, that means our vertex is right there. And so if we had 1 here, and 1 squared is 1, minus 1 is 0. So our first point we can extra draw on the graph is here. And if you plug in minus 1, we get that point. If we plug in 2, 2 squared is 4, minus 1 is 3. So 2, 1, 2, 3, and then minus 2, 3. And so it's going to look something like this. And again, I'm not the best drawer on the computer. All right, so now we want to look and see, okay, what regions do we have? Well, we have a region in here, and we have a region out here. So technically there's two regions. So star 1, star 2. Well, if we think about that, okay, well, star 1, star 2. It says that our y has to be greater than or equal to that line. And so we have a solid line, and so it has to be greater than or equal to that. To be able to do that, that really has to be in this region here. And so let's pick the simplest one possible. The simplest possible one in this region is that. The simplest possible one out here would be that. So for the star, we're going to choose 0, 0. So 0 greater than or equal to 0 squared minus 1. 0 greater than or equal to a negative 1. Yep, that's true. So for sure, we're going to shade in that area. But what about this other one? Well, the other one was a 0 minus 2. So we're going to have 0 for x and minus 2 for the y. So minus 2 greater than or equal to 0 squared minus 1. Minus 2 greater than or equal to a negative 1. That's false. And so we're not going to shade out here. And maybe to do the shading, maybe do a highlighter. And so it's going to be this region here that's shaded. And remember, it's going to go all the way up, however far our parabola goes. So it's going to keep going and going and going. Okay. And so that's how we're going to do it. And again, we draw just whatever the graph was given to us. Then we have to check a region inside and outside. And like I said, when I look at this, we had to have y greater than or equal to this parabola. And so to be greater than or equal to, it had to be up in this region here. And so that one kind of clued me in on, that should be my test region, maybe the 0, 0, since it's easy, and that one would work. Okay. So let's do some more of these. Okay, here we have a system. So we have to do, two things. We'll have y equals x squared minus 1. Well, that's the same one we just did. And the next one is x minus y equals negative 1. All right, well, since we know we had a point here, and what was that, 3, and then this one was at 3, this one was at there. Then what we have is we have something like that, and I don't know where my other line comes in, so I'm going to draw it up a little higher. So that's that one, and we have greater than or equal to, so luckily I can do that with a solid line. Now this one, I need to solve for y. So if I subtract x and subtract x, negative y equals negative x minus 1. And if I multiply everything by negative 1, I get y equals x plus 1. So I'm going to have the intercept 0, 1. And maybe I'll draw this one in a different color to kind of differentiate. So 0, 1 is here. And then I'm going to go up 1, right 1 because of my slope, okay? So I'll go up 1, right 1, and I can go down 1, left 1. And so it's going to look something like that, okay? Now, what do we know? Well, we know for this one, it's going to be greater than. So it's going to be, up here again. So we already know that that means it's up in this area. Now, what does this one say? Well, let's go ahead and think about if we would go and solve this with the inequality. If we would do that, I would add y to both sides. And so then I would get x is greater than or equal to y minus 1. Then I'd add 1 to both sides. And so x plus 1 is greater than or equal to y. And if I read it backwards, y is less than or equal to the x plus 1, then I could rewrite it like this. And so I'm going to have something below that line. So the one is going to be above, the other one's going to be below. Well, the only region that's above and below in that region is going to be here. So I'm going to choose that 0, 0 again. Now, like I said, we could choose a whole bunch of points. We could choose also maybe this point, and we could choose some point out here, maybe this point, because we're going to have it here. And because this splits it here, we could choose a point here too. But I'm pretty confident, based on how my inequalities are set up, that we know it's going to be less than the x plus 1 line. And so it's going to be everything down here. It's going to be greater than or equal to the x squared minus 1 line. And so it's going to be going everything up here. And the only place they overlap is right there. And so let's test that. And so if we plug in 0, 0, we have 0 greater than or equal to 0 squared minus 1, 0 greater than or equal to a negative 1. It works for the first one. And on the next one, 0 minus 0 is greater than or equal to negative 1, and 0 is greater than or equal to negative 1. So that works. And so, like I said, we're going to first mark that. Oops, I don't want the pen to be that. I just want the highlighter. There we go. So this, in this area, is really what I think the only thing that's going to work. Now again, what we're going to do is we're going to test other areas. We're going to test maybe this one. 1, 2, 3, so minus 3, 0. So we have that. And so 0 is going to be y is greater than or equal to negative 3 squared minus 1. And so 0 is going to be greater than 9 minus 1, which is 8. And that's false. And so we don't even have to worry after that, because that's not going to be a case. What about this one here? That's going to be a 0 minus 2. And if you remember, we did that one already for the other one. So if we plug in a minus 2 here, is that greater than a minus 1? No, that one's false. And so if we plug in something way over here, say we have 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. So 4, 7. Well, here we have 7 greater than or equal to, and that's going to be a 4 squared minus 1, so 16 minus 1. Well, that's false as well. So we can see our intuition told us that should be where it is, and then we chose that point and it was working. And so we really didn't have to test all those other points as long as we kind of knew what it was. All right, so that's into part 4, and I'll come back and we'll do some more graphing.